Forgive me for beginning the tape walking in front of the camera, but I don't have much of a choice here. This experiment number 3 involves this curved end ramp. You might be able to see that the end is curved. If I lay down on the table and push down on this end, you can see how the end is curved, although it's not at all curved in this end. Or if I push down here or here, until I get about here, there isn't any significant curvature. Now I take the doubled ramp. This fits on a balance, and you'll see how that works later. It's got a weight hanging from it. I'm going to tuck that cylindrical brass weight here. I'm going to tuck that brass weight underneath and lay this down on the table. And I'm going to take some coins. Coins are convenient. And I'm going to adjust this ramp until the ball, when released, tends to move along at a fairly constant velocity. The ball is still wanting to stop, so I don't think that we're up high enough. I had a quarter under there. I'm going to put another dime under there, and now the ball 1, 2, 3, 4, slowing down. I'm counting the time it takes. I'm just kind of counting when it passes little round circles, little round holes that you'll see in the top of this ramp. If I give it a push, 1, 2, 3, 4, 5, 6, 7, and I hit it with my fingers, naturally it slowed down. It's still slowing down a little bit as we go down this ramp. I'm going to try another nudge. Just give it a small nudge here, and let's see, 1, 2, 3, 4, 5, 6, 7, 8. Fairly constant speed there. This ramp isn't completely level, so we're never going to achieve completely constant speed. Now I'm going to, what I've got here is a couple bottle caps, but you can use anything. Put that under the edge here. Make sure that if I go from here to here, from one ramp to the other, the ball will fall down and not up. Looks like I've got to get that up a little bit higher, so that at the end of the ramp, the ball wants to go straight. Okay, that's about right. The ball kind of goes toward the end of the ramp. Now, going to take a measuring device. I'm using a meter stick here. You can use your tape measure, whatever. And I'm going to position this in order to measure my distance back along the first ramp. And I'm going to let the ball coast from the 20 centimeter mark, from the 25 centimeter mark, wherever, onto the first ramp. Now, as the ball coasts from the first ramp to the second, I'm going to want to measure how long it takes to travel the distance down the first ramp and the distance along the second ramp. And let me stop for a minute. I've got the curved end at the low end here, and I really don't want that. I want the curved end at the high end of this ramp. And again, I want the ball to be able to roll from the first ramp to the second without any little glitch in the motion. I'm going to put a dime under the first ramp. The ball falling from the first ramp a short distance to the second doesn't really do any harm. Now, I'm going to start 10 centimeters from the end of the first ramp, then 20, then 30, 40, 50, and so forth. I can reduce the slope to make it a little bit easier to time the situation if I don't knock everything over. And now I'm going to use the computer timer, where I simply hit the T key, and I'm going to time from release to here to there. Now there is a point on the second ramp. The easiest way to determine if the ball has reached that desired point in the second ramp is to put an obstacle in the way. We won't normally use the friction truck, but it's the only thing I have handy here. So again, on the timer program, I hit the T key at release, there, and there. And I'll be able to read off how long it took the ball to go from here to here, and then from here to here. That's how we're going to collect data. Then you're going to determine average velocities and do some graphs, and you're going to follow the instructions. Of course, if you have questions, you email me one way or another. Get my input to help you out.